So yeah, like Justin said, Daryl and I are going to cover the updates to private VLAN. So of course, we'll give a quick overview and review of PVLANs. We'll talk about some use cases and give you guys some information about details and caveats, as well as troubleshooting, and then we'll end it up with a demo. So, as review for private VLAN is an extension of a regular VLAN, which helps us to restrict traffic between users on the same VLAN. A PVLAN consists of a regular VLAN, which is partitioned into primary and secondary VLANs. And the partitioned regular VLAN becomes the primary VLAN, while the secondary VLANs are associated with that primary VLAN. They'll have unique VLAN IDs. And of course, there's different types. There's isolated and community. And depending on the type, that will determine on how and where the packets can be forwarded. Promiscuous, when we're looking at a promiscuous VLAN, a promiscuous port is going to be belonging to the primary VLAN, and that can communicate with all of the interfaces, including the community and isolated host ports that belong to the secondary VLANs, which have been associated with that primary VLAN. Typically, a promiscuous port is a switch port that's going to be connected to like a router or a firewall, a layer 3 switch, or other common gateway type devices. Isolated, so an isolated VLAN or port, this is providing us with a complete layer 2 separation from other ports that are going to be within that same private VLAN, except of course for the promiscuous ports. So traffic received on an isolated port is only going to be forwarded to those promiscuous ports. A community port is going to be a host port that belongs to a community secondary VLAN. And these community ports can communicate with other ports in the same community VLAN, as well as with that promiscuous port. And when we're looking at like PVLAN over our ISL links, so the PVLAN domain is going to be extended across the devices using that VSX ISL, provided, of course, that we have the configurations the same on both of the devices. Now that ISL port can carry both the primary and the secondary VLAN. In fact, the recommendation is really to configure that ISL port as a trunk allowed all. And then of course, there's no real additional specific PVLAN configurations that are going to be required on that specific ISL port. Taking a look at just some of the capabilities and restrictions that we should be aware of when we're thinking about deploying a PVLAN solution. Promiscuous or primary ports, they can be a member of multiple primary VLANs, and they can be a member of multiple normal VLANs, but they cannot be a member of secondary VLANs, even those that may be mapped to other primary VLANs. Secondary ports can be a member of the multiple isolated community VLANs, which are mapped to different primary VLANs, and they can be members of multiple normal VLANs also, but they cannot be members of any multiple secondary VLANs for a given primary VLAN. When we're looking at the PVLAN features, it cannot be enabled when some features have been enabled, such as VLAN translation, GVRP, RPVST, or MVRP. Take note that the default VLAN, that cannot be configured as a primary or secondary VLAN, and secondary VLANs cannot have an IP address, an SVI interface. And each secondary VLAN is limited to one primary VLAN per secondary VLAN. Some other things to state details to be aware of with regard to PVLAN. With regard to the operational state, if the primary VLAN is administratively down, all of its secondary VLANs are going to be down with that reason that shows PVLAN primary down. And if the secondary VLAN is set to be administratively down, it's going to be ignored. If there is no primary VLAN associated for a secondary VLAN, then that secondary VLAN is going to be set to down. Some additional configuration limitations. I think the VLAN 1 cannot be configured as a private VLAN. An access port, which is going to be directly connected to a host, that can belong to one secondary VLAN in that primary VLAN only. And promiscuous ports can be members of the primary VLAN only. And of course, ports can be only one type, either promiscuous or secondary. And there's a number of features that we actually can only be enabled at the primary SBI. Those are listed in the bottom there. So local proxy ARP, the IPv4 or v6 addressing scheme, DHCP server configurations, BGP, OSPF are great examples of those that can only be configured at the primary VLAN. Now, when we're taking a look at the use cases and the platforms, so really a good example of a good use case for primary VLANs, of course, is a hotel room. So like where hosts from multiple rooms are going to be connected in the same VLAN. In those types of situations, it's going to be desirable that traffic from one room is only going to go to the gateway and not to the other rooms. Now there can be a number of ways that customers could achieve this. One way might be to assign a separate VLAN for each room in the hotel. But the issue there is that each VLAN is going to have its own IP subnet, and managing that infrastructure is going to be a difficult task. Another option may be ACLs and port filters to isolate traffic between the ports, but this can become a management nightmare, as those types of scenarios are going to have often configuration changes with adding and deleting and moving users, as well as ACL and port filters can become scarce resources when you're configuring tons of them. When we're looking at community VLANs, those may be very similar, except these are going to be oftentimes seen like with multiple small tenants. So think of like a shopping center where we've got many small shops with wired connections that need to have separation from the other shops. When we're looking at data center environments, isolated VLANs are commonly going to be used like as a backup network. So where all of the devices in that isolated VLAN will need to send information to that backup server or cluster. Or another example in a data center would be like a multi-tenant data center where we're going to be using community VLANs. Now, in 10.8, PVLAN was enabled for the CX switches that we see on the upper right, the 6200, the 6300, the 64, and the 8360. But with 10.9, we've added PVLAN support to the CX 8325, as well as the 10,000 switch. So take note, though, that the bottom four switches, the 6100, the 4100i, the 8320, and the 8400, do not support PVLAN. So when we're looking a little bit more at the details and caveats for 10.9, VXLAN PVLAN is enabled, and Daryl's going to give us a demo of that. When we're looking at PVLAN with regards to PIM solutions, and those solutions, PIM can be enabled only on that primary VLAN SBI. And PIM, of course, handles the unknown multicast on a VLAN when it is enabled on an SBI. And of course, we have support for enabling layer 3 multicast and unicast on the primary VLANs on a device where there's also a secondary VLAN mapping for those devices. But of course, take note that the layer 3 configuration is never going to be configured on the secondary VLANs. With regards to IGMP snooping, this is enabled and disabled on the primary VLAN. And once it's enabled and disabled on that primary VLAN, it will automatically be enabled and disabled on any of the secondary associated VLANs. And if we do create a secondary VLAN and snooping is enabled, any of those new secondary VLANs are automatically going to inherit that IGMP snooping configuration from the primary VLAN that they've been associated on. When a query, a join, a leave query is received on a primary VLAN, it's going to be replicated to all of the secondary VLANs. And of course, if it's received on a community or an isolated VLAN, it's going to be replicated to the corresponding primary VLAN. We have both VSF and VSX support. So VSF support on the 6200 and 6300, which supports failover as well. And the secondary and promiscuous ports can be on any member device in that stack. And we have VSX support for the 6400, the 8360, the 8325, and the 10K. And in those situations, MC lag can be a PVLAN port. And of course, that PVLAN config will be synced across to that standby VSX peer in those solutions. Taking a look at the scale of our PVLAN deployment. So when we're talking about the maximum number of private primary VLANs, the 62, 63, 64, 8360, and 8325 max out at 32, while the new CX 10,000 can actually support up to 512. All of the switches support a maximum of 24 secondary VLANs per primary VLAN. And when we're looking at that number of physical ports that can be used in a PVLAN, on the 62, 63, 64, and 8360, we max out at 24. But at the 8325 and the 10K level, there actually is no limit on the physical ports there. And of course, we can use the show capacities private VLAN command to get an idea of the capacities on our chosen device. Some basic configurations for primary and secondary VLANs, right? So we would create a primary VLAN, VLAN 1100 in this case, and use the private VLAN primary command. And when we're creating secondary VLANs, we would use the private VLAN either community or isolated command, and then we would associate that with the primary VLAN that we wanted to associate that with. When we go to the physical port, we can actually log into the physical port and assign the physical port the port type. So 119 in this example is going to be a private VLAN port type secondary. And then, of course, the interface lag at the other example is going to be our promiscuous port for our uplinks. Wanted to give a few scenario examples. So here's a layer 2 multicast PVLAN scenario where switch 2 is going to receive this IGMP join on the primary VLAN. So that join is going to be sent to switch 2 via port 5, which is going to be the query port on switch 1. And of course, that join is going to be replicated to the primary if it's received on a secondary VLAN. Switch 2 port 10 is going to receive that original join from switch 1, and it's going to go ahead and forward it to port 11. And of course, typical behavior is it's going to replicate that join to any secondary VLANs on switch 2, but that replicated join isn't going to be forwarded back to switch 1. And then, of course, finally, switch 1 is going to receive the multicast traffic stream on port 5 from switch 2. And of course, switch 1 will forward it off to port 1 that needs to receive that stream. When we're looking at a PIM-enabled solution, so the join is going to be received on switch 1, port 1 from client 2 in VLAN 20, and that join is going to be replicated to the primary VLAN 100. And then switch 2, port 10 is going to receive that join from switch 1, and it's going to forward it to port 11. And that join is going to be replicated again to any community or isolated VLAN on switch 2, but it won't be forwarded back to switch 1 over that link that it received it on. And then finally, of course, that routed multicast traffic received will be received on switch 1, port 5. It's going to be forwarded to the initiator on port 1. When we're taking a look at VXLAN, PVLAN, so of course, VXLAN private VLAN is providing us with this layer 2 segmentation. In these solutions, we support IPv4 and IPv6 unicast traffic only. Of course, hosts within the same community VLAN are going to have network connectivity. Hosts in isolated VLANs will not have network connectivity with the other PVLAN hosts. But hosts are going to be able to reach their default gateway in that private VLAN. And these solutions with VXLAN is actually going to be supported on all the switches we see here. So the 63, 64, 8325, 8360, 8400, as well as the new CX 10,000 switch. Just some caveats that we should be aware of. So we can't have a server-facing port with multiple secondary VLANs. So these are the community and isolated VLANs. We can't have a server-facing port with multiple ones of those which have been associated to the same primary VLAN. However, if the server has a vSwitch or a blade switch that is PVLAN aware, then this example that we're showing right here can actually be done. It's mandatory oftentimes to add that private VLAN port type secondary to these server-facing ports for PVLAN to function. However, again, in this example, if the server has a vSwitch or a blade switch that's PVLAN aware, and it has the secondary VLANs configured on it, then this private VLAN port type secondary command isn't actually required. Some more caveats. So with regards to server-facing ports, they can have a normal and a secondary VLAN. However, the normal VLAN, in this example, normal VLAN 30 hosts, they're not going to be able to reach their default gateway on SVI 10, which is used by PVLAN. So of course, the solution here would be to move these normal VLAN hosts to a different subnet. So we would move the VLAN 30 segment range to, let's say, 30.1.1.x segment range. And of course, that segment range would utilize its own default gateway. Some quick reviews of troubleshooting. So when we're troubleshooting, of course, we want to check the PVLAN configs are correctly configured. So, you can refer to that config slide for those sample configs on that. We want to verify the PVLAN associations. We want to verify that the correct isolated and community VLANs have been associated with the proper primary VLAN. And of course, that should be consistent on all connected switches. We can run the show private VLAN association command, a quick and easy way to see the primary mapped to which isolated and community VLANs. And then there's also the PVLAN inconsistency command. So show primary private VLAN inconsistency, which can be used to check to see other issues. In this example here, we could see the interface is down, and the interface is actually a member of both a primary and a secondary VLAN, which it can't be. And then finally, we want to verify the PVLAN port type is correctly configured, right? So as I mentioned, it can be mandatory to add that private VLAN port type secondary to server-facing hosts. However, again, like if that server-facing host has a vSwitch that's PVLAN aware, then that command may not be required. In this example, we've got an example of that command being used, so we could see that applied to port 111. And we can also check to see if that command has been used by doing the show private VLAN port type command. And of course, we want to verify that traffic between hosts is going to be, allowed or blocked as we would expect. So we would test traffic between the hosts. And of course, sometimes packet captures might be required to help further diagnose the issue. Of course, if we wanted to configure it to mirror traffic, we've got a simple configuration example of enabling a mirror session. And when we're looking at VXLAN troubleshooting, I mean, not surprisingly, when we're troubleshooting these solutions, we want to have a topology and a diagram ready. We want to ensure, of course, that the IPs, the interfaces, and the details are all included. Of course, we want to check the physical cabling and generate possibly a show tech command when we're going to be opening a TAC case. Show LLDP neighbor can help us with that, of course, with the checking the networks command. And if it is a VXLAN PVLAN, we want to ensure that that underlay network using ping and trace route between the loopbacks interfaces is working. And of course, if it's not, we want to resolve that by fixing any issues that may be found. And I think we're going to jump right over into the demo for Daryl.
Okay, let me share my screen.
Oh, there we go.
All right, hope you see the screen.
Yep.
Yep. Okay, so let's run through the demo setup I have for VXLAN PVLAN. So the objective is to provide layer 2 segmentation. Right. Take note, it's only for unicast traffic, but it applies to both IPv4 and IPv6. So PVLAN VXLAN only works with IPv4, IPv6 unicast. You can see here, this is my setup. I have a primary VLAN, the green one. Okay, that will be the default gateway, okay, for the 2011 subnet. And that's on the distributed gateway, you can see here. Switch 1 and switch 2 have the same default gateway. Okay, I have a blue VLAN, community, VLAN 20. That's on this subnet, right? That's attached to the primary VLAN. So that's blue. So community means they can communicate within them and they can communicate the gateway. And I also have a black normal VLAN 30. So this is normal. There's nothing to do with PVLAN. I just want to show you that what happens if you mix PVLAN with normal VLANs on different subnets. Right? They're not on the same subnet. So, and I'm going to show you that after that, you can actually change it. If you want to isolate hosts on like the secondary VLAN, you can change from community to isolated. So you can isolate all the hosts from communicating with each other, but they can still get out. They can still reach the default gateway. They can still get out of the subnet to reach a normal VLAN 30. So that's the objective of this demo. Let's take a look at the setup. The configs first. PVLAN config. Really simple. What you need to do, specific to PVLANs, is create a primary VLAN, attach it to whatever desired VLAN you want, create another VLAN, and specify whether it's community or isolated, and link it to the primary VLAN. That's all you need to do. And at the port level, port 1, okay, so you can see there's a port type secondary. You can allow your secondary VLANs and your normal VLANs. Okay, so you need to specify this port type secondary. If your server doesn't support PVLANs, of course, if the hypervisor supports PVLANs, you do not need to configure that secondary command. So that's it for PVLAN config, right? Just a few lines and you can get that isolation. So let me go into the host perspective. Let's go to 1.21, this VM, 1.21, right? You see this IP here. Let's try to do some pings to verify connectivity. So this is same subnet, 1.23 here. So why is it communicating? Why? Because it's on the same community VLAN. Okay. Let's also verify. You can reach other subnets. 30, 23 here. So you can reach the normal VLAN as well. You route. So that connectivity is working. Let's look from a MAC address learning perspective. What do we see? Okay. So if we look at the MAC table, we can see MAC address. So this was the VM I was on, 1.21. The MAC address is A695. If you look for A695, you can see it's dynamically learn PVLAN on this port. This is local port. A695. If you look at the normal VLAN, VLAN 30, FB12. FB12, you can see it's on VLAN 30. It's dynamic on the same port. You can see the difference, right? A normal VLAN is only stated dynamically learn, but if it's PVLAN, it has the dynamic PVLAN word here, the MAC address. And the remote MACs, for example, 2311 and 8AC4. 2311, you can see it's done via VXLAN EVPN. And 8AC4, same thing. So the remote ones, they do not show PVLAN, but they show as how they learn via EVPN, right? Only locally learned MAC addresses are shown as dynamic PVLAN. Okay. So you can verify. This way. You can see the associated VLANs in the communities. So here comes the part where we want to make the change. I'm going to basically run the pings from 21 to 23, and they should be allowed now because they're community. I want to change them from community to isolated VLAN. So we should have that traffic loss immediately on both switches. So basically, in VLAN 20, you just change it from community to isolated to activate that. Okay. So here is the other switch. Let's run the pings. Okay. So now it's community. Let's change them to isolated here and here. Isolated. You can see they no longer have communication anymore because they are on isolated VLAN. And again, you can verify, show VLAN association. Right, 20 is isolated. There's no more community. Okay. So basically, we have changed the blue community VLAN 20 to a red one, and we show that they are isolated on the same VLAN. We have L2 segmentation for hosts on the same VLAN. What about connectivity to outside of the subnet? So let's check that. So they can reach outside of the normal. You can see that. And they will be able to reach their gateways as well on the primary VLAN. can see, right? Default gateway works as well. So if you change it to isolated, they're only isolated within the same isolated VLAN, as well as they can't communicate with other community VLANs. But they will be able to reach the primary and other normal VLANs that they route to. Okay, so that was the demo. And I think that's it. We're right on time.